Hi everyone, welcome back to Grade 10 Maths with Mr. Simons, right, where we make maths easy and we get you exam ready. Right now, this is the first set of exam questions I'm going to do, starting with Grade 10, November 2016. Right, and this question is an interpretation question, meaning we've given you a graph. Graphs are drawn and you must be able to answer questions from the graph. Question is looking around a sine and a cosine graph. Right, so I hope along the way I get you to understand better. It's very important that you get to understand how exam questions function. Right, so if you look here, it was question 6, generally question 6, other papers question 5, sometimes question 4, but generally, as I say, question 6. So the question says the graph of fx equal a sine x and gx equal cos x plus 1 for x element 0 to 360, sketch below. So there when you say 0 to 360, you see it starts by 0, graph ends by 360. There small f, so this graph here is my sine graph. Those of you doing physics have also done that. The sine graph always has, in physics, crest and a trough. Right, that's when we do wave sound and light. We look at our transverse wave operate, right? Then we have the cos graph. As you can see, it starts by 2, goes down and back. So it doesn't go below 0, right? So the first thing, they want the value of a there. Then they want the period, meaning where does the graph start and where does it end to form one complete. Range, what's the highest the graph is going to and the lowest. So I'm just giving you explanation of what we're asking. 6.4 for which values of x. If x is element 0 to 360, will fx times gx be greater than 0? So we're asking where is the one graph positive and the other one positive. So we get positive times positive is greater than 0. Where is the one graph negative times negative and greater than 0? Then general question, and this is with all graphs. We give you a graph that's translated and shifted or reflected, and you must be able to write a new equation. So I say graph of g is reflected about the x-axis and then shifted 3 units upwards, so I should read 2 units upwards to obtain the graphs of h. Write down the equation of h. So they have made a error, but yeah, in the slide, the other slide, when I do the answers, that reads 2 units. I by mistake typed 2 units, so my apologies. Right, so you can pause here, look at the question, attempt to answer some of it. So you have idea what you are able to answer and what you can't. So that when you start looking at my explanations, you have idea of what is important for you to listen to and what you need to improve. That is why we practice past the exam questions. What we do in class is not always in line with what you will see in exam. All right? It's much as the nature of how textbooks are written. Right, so let's look at the first 2 questions. Right, so the first question says write down the value of a. So remember they gave fx equal a sine x. Right, so if you look at the sine graph there that I've recolored in red, right, the highest point it goes there to is 2. The lowest point it goes here to is minus 2. If we go in the middle of it, from the middle to the highest point, from 0 to 2, we're moving 2 units. So a being the amplitude, a equal 2. So that's to go from 0 to 2 is 2 units. All right. So therefore a is 2. So whatever's here in the front, we're always looking at the amplitude of the graph. Right. Then they want the period of f. So f, there as you can see it says x. So naturally you should then know the natural period of a sine graph is 360. But if you want to look there, the crest there, the top, and the bottom of the sine graph there, put together goes from 0 to 360, which I've colored there for you in blue. So therefore my period equal 360 degrees. So whenever we ask period, we want one complete graph. One complete graph from the beginning, where do we start, to the end. We subtract that to 360 minus 0 would give me 360 degrees for my period. For amplitude, we go to the middle of the complete graph and we go to the highest point. So from the middle to the highest point here is 2. Therefore, A there is 2. So I hope you understand, and we still together. Let's look at the next set of questions. Alright, now 6.3, they say write down the range of G. So whenever we ask range, we want to know on the y-axis, where's the smallest value we start from and where's the highest value we're going to. Right, so there in purple, there's the graph of G, G of x. So you can see the lowest point it reaches there is 0, and the highest point it goes to is 2. Therefore, my range, we would say y less or equal to 2 or greater or equal to 0. So it's bigger than the 0, yeah, or equal to it, but less or equal to 2. So that means it goes from 0 to 2. Right? You can also write it as y element, square brackets, meaning 0 is included. So it starts by 0 and it ends exactly at 2, therefore square brackets. If I used open parentheses or open brackets, then that means 0 and 2, it almost touches 2 and almost touches 0. So therefore, we have square brackets because it makes contact with 0 and it makes contact with 2. Right, so I hope you follow for range. 2 relatively easy marks once you get used to the concept. If you're not, go look at the previous concepts where we do range. Right, 6.4, for which values of x, for x element from 0 to 360, meaning from there to there, is fx times gx greater than 0. So where is f of x positive and g of x positive? Because positive times positive gives me a positive value which is bigger than 0. Or where is f of x negative and g of x negative? Because negative times negative also gives me positive, and a positive is greater than 0. So if we look here from 0 to 360, right, the red is above the x-axis. So that means that y value is there for the red is positive. Same with the purple, from there to there, the g of x is positive, it's above the x-axis. So from 0 to 180, f of x and g of x is positive, right? So therefore, my first x greater than 0 or x less than 180. Right, now if you look at the second portion, the f of x becomes negative, but you see the g of x stays positive. So positive times negative is negative. So at this junction between 180 to 360, the two of them are different signs, meaning they are less than 0 there if we multiply them. Right, so my answer therefore is only valid from 0 to 180. Right, so hope you follow and understand. I just use the greater sign because there they just said greater than. If it said greater and equal to, then that would have read x greater and equal to 0. Right, so hope it makes sense. So positive times positive is positive, but positive times negative is negative, so 180 to 360 not valid. Right, 6.5, the graph of G is reflected about the x-axis and then shifted 2 units upwards. So very important. We first reflect, and after reflecting, then we shift 2 units upwards to obtain the graph of H. Write down the equation of H. Right, so g of x, equation was given as cos x plus 1. Now when you say reflection of our x-axis, my x and y tends to x and negative y, meaning if I reflect about the x-axis, my x values stay the same. See there, x and x stayed positive, positive. But if the y is positive, y would become negative. If y was negative there, y would become positive there. Right, so for the reflection of the x-axis there, you can see, first I make the y value, which in this case is h of x, as negative, because that's the equation of h. Cos x plus 1. So if I multiply the negative away, that would become positive times negative, negative cos x, positive 1 times negative, negative 1. So after it's reflected, now I'm shifting 2 units upwards. So to shift 2 units upwards, plus 2. If I work with the error I typed in the beginning and I said 3, that would have just read plus 3 units. Does that make sense? Right? I hope it does. Right? So 2 minus 1 gives me plus 1. So my new equation, minus cos x plus 1. Right, so 1 mark for making that negative, another mark for making that positive. Here are the 2 marks, 1 mark for the critical values 0, 0 and 180, and another mark for the inequality signs being correct. Right, the same thing with the range, 1 mark for the critical values and 1 mark for my inequality signs being correct direction. Right, I hope you enjoyed the lesson. If you like it, please subscribe so that you in tune and you know when I'm uploading the next lesson. Continue practicing. As I said, I'm going to try to upload as many problems from November 2016 all the way to currently November 2024, so that you have as many CAPS past exam questions to practice and go through. Right? I just know the harder you work and the more you practice, the easier maths becomes. God bless. Bye.